So we didn't have any new tools for a while. I was trying to update this one. Well, first, it could use need to rearrange the size of everything on the screen. And I was also saying that this mean value, it's actually the mean and confidence interval. So the upper and lower 95 percentile. That's the actual API in Labview. So this is what actually doing all the calculations. And the visual stuff is in here. And in here, the idea was to actually plot these numbers over time. And every time you actually change something, it will give you the reading again. It doesn't work as expected, not just yet. And the idea was for it to have three separate charts in one showing the median, and the other two showing the upper and lower percentiles. But as I said, that yeah, this is another bug. Sometimes you will change parameters and just not show anything at all. Right now it's working again. So I'm not. That's another thing that needs to be fixed. Uh, so yeah, that would be just a different way of displaying this value. So instead of displaying the one that you get for specific settings, it will just keep the memory essentially of what the values were prior. And what else were we doing? Yes, so we did change this tool quite recently. We added a feature where you actually slide the bar here. It will keep updating the output. I don't know if it's a bit annoying or unusual. Let me know. So the idea is that you can change the settings and the graphs will get updated without you having to click this train neural network button over and over again. And the other thing is that I was trying to figure out if this button is actually doing something useful or not. It is changing sometimes. In theory, I thought it's when actually this probably should just go to 0. Maybe. So in this case, it is an LED, it's an output, and when it's white, it's off, and when it's blue, it's on. I can change it to green, but the background is a bit greenish, so I'll leave it blue. And in theory, when this when the algorithm thinks, or the algorithm doesn't think, does it? But whenever certain thresholds being reached, I'm pretty sure it's the error trend. When it's low enough, then it's maybe it needs to be 0, very close to 0, and then that's LED is going on. So maybe it's. I didn't actually realize. I thought that was 0. I can actually fix it now. Yeah, now it's 5.6, 2.1, 7, 3, 6. Right, so actually now I understand it better. Yeah, in this case, yeah, every time you have these spikes in the errors, you get some weird results. Yeah, it's all different. Anyway, 3.8. I was just wondering if this number essentially below a certain threshold, then this LED uh, will turn on. Yeah, this is very wrong. I actually didn't have anything as wrong as this one. Anyway, back to this. Just trying to figure out when this goal reached LED is turning on, and the hypothesis is that it happens when this arrow trend is saturating at 0 or very close to 0. I can actually increase. In theory, this should reduce the error. Should this reduce the error? No. Yeah, when you get this spikes in error, you get all sorts of funky things happening there. That's nothing to do with. I think that's nothing to. No, that's actually not time. That's the number of iterations. That is time. So I actually have to correct that. Thanks for. Oh no. Yeah, someone could have let me know ages ago. But yes, perhaps it wasn't even clear. But now I'm just trying to figure out when. So yeah, just notice when you actually go to more hidden layers, this number drop. No, it keeps doing rubbish. 1.9. Yeah, I think before the numbers were higher, but I'm not sure. Anyway, maybe when it goes below 1 or 0.5 or something, I have to check the code. This LED should turn itself on. Ah, this? No. The numbers be. Right, well, this is bizarre. Wait, I'll just reload the page. So, yeah, when you reload the page, the values go to default. But what's happening there? Yes, so the number. So bizarrely enough, when the training size is lower, yeah, when this number is very close to 0, this LED turns itself off. Right, so it seemed to work. I'm not sure what the exact threshold is, but yes, I thought that should happen with a higher training set size. But yeah, must be. Yeah, so in this case, okay, I think I know what it's doing. So because yeah, for some reason the error is lower when it doesn't mean that it will give you something correct. It could still do mistakes. It's just that the calculated error trend is overall lower and says that the goal is reached. And it actually also shows you like how long it took for it to get there. So in this case, it's actually making a prediction that this is not a sinusoid. In fact, it is a sinusoid. Well, I mean, if you have a larger training set, then it looks more like a sinusoid. But in this case, it predicts that it's this type of shape. So it's like an oscillation and then it's dying out. So when you say like a load release a spring and then it's over time dying out, so the blue is what's being predicted, and the algorithm says that there is almost zero error in this prediction, and this LED is going on to indicate that the answer slash goal was reached. So yeah, and here it will show you a different result essentially for the same signal, and it's still highly confident. So I guess, I don't know, I haven't used Chat GPT. Apparently it's still free, so you can probably should go and try it. but it's essentially when the language processor, the chatbot, is giving you something and it's very confident, but it's actually giving you a wrong answer, but with a very high confidence level that yes, I'm correct, but obviously the answer is wrong. And this is an interesting case as well, where yeah, this is the prediction and the error overall, it's reached essentially zero error quite quickly in a relatively small number of iterations, and it's saying goal reached. So I'm right, and you have to make whatever you want out of it. So that's generally how neural networks and any other fancy algorithms work. You have to keep testing. You have to ideally have the source code so you know what they're doing. Again, I showed this before, but I can show you again quickly the this is the code that is just, it's not actually doing much, it's just uh, displaying the graphics. So that's the web app, and then it's the HTML is actually calling this API, which again anyone can access. So you can go and do this. So if I execute it once, you can go to this API. If you copy paste this and go to any to your browser, you paste this, and it should just give you the raw numbers. So if you know how to read them, which that's essentially what I'm showing right now, you could go and create your own user interface for this, which is awesome. And yes, let me know if you do. Um, well, yes, this is all released under Creative Commons with attribution. So you'll have to, if you do use it, you just have to mention where you get it from. So have a, well, I expect like a link to the original, uh, at least, hopefully my like YouTube videos as well. And yeah, you can create your own web application for this, and the actual web application is running in Labview. It's under test web resources. Right, this is the actual web application. Uh, don't remember. I'm pretty sure. I have to check if I must have started off some sample code as well, which I do mention in here, right? So it's a modified from Labview example, and this is the link. I don't know why the link is not clickable, but you can go. Someone posted a sample example code on National Instruments forum, so you can go and look at that as well. And I have to make attribution if I used anything from someone else. And this is it. I'm pretty sure I added this bit, which is what what's streaming online. And it would not run in Labview anymore because it's a web app, an API. It's there's another tool turning this into API, so the website can access it. Yeah, it wouldn't even run once in here. So I need the original version for it for me to run it in Labview itself. Originally, there were a lot of these tools, like this one, had they were automatically playing the file, but now it's turned off, so you actually have to click it manually. Back. Right, I need stuff that I can actually publish. Yeah, that's not much. Again, this is for if anyone wants to use the APIs. Can set you up with that. What else were we doing? Yes. Right, this thing I wanted to correct. So for example, I want to correct a few things. I want this to go to 0 all the time. This is the amplitude. And I want it to know auto scale. I want right. This is actually quite handy. You can grow only. So this meant to have a hover over as well, but for some reason it doesn't work. Check hover, value hover, and this one I actually want the hover value. So this array, I want the last value of it. So it should be something array subset. Can just get one. So from this array, I want the last value. And so you also need the array size. I'm getting array size. And array size going into index. And this, I want this subarray. No, this should be just one. Oh crap. It should be just one number. Okay. Why this should be just automated, so when the length of the be minus one though. I'll just test this. Test. This doesn't return anything, yes, because it needs to be a minus one from numeric minus one. Now it should get get the 2.5. Well, it's the I guess it's the non-rounded 1.63. Yeah, 1.63. You can't see it. I'll make it bigger. Yeah, and it should be just the one value. So this array should be index. This is better. I used the wrong function. So this will be, should be called the last element. Place it here in the meantime. Make it bigger. Last element. Right. 1.18. 0.11. This LED didn't go. It didn't go on. Right. That's like. Yeah, I'm not sure about this function there. It's the amplitude is the auto scale. I fit loosely. Keep it. No. Can we have that as input? We can create a reference graph 4. This one will have y. Was active while scale. Oops. Yeah, that's the problem at the moment is that yeah, if you scroll this one too many times, it will keep giving you answers. There's someone screaming outside. We'll have to edit it out in the video. Scale. So this active scale, blah blah blah. Amplitude. To grow. I thought that will change to 1 or something. No, it didn't. So axis, scale, auto scale. Oops. Wrong button. Uh, yeah, Labview. Uh, Labview is good, but this G web development by NI is quite limited. I don't see that option. So at the moment, I just have the auto growing. So when you have this number lower, it will keep 100. And if by any chance it's going higher, like 120, 125, it will set it higher and then leave it at that. But um, yeah, I guess so far, amplitude, auto scale, grow only. No, so if we don't do auto scale, just keeping it from, well, yeah, minimum 0 and maximum, say, let's make it 15 or something. So in this case, yeah, the scale will not change. We get the last element in there, 2.4. Um, and we can see, yeah, we don't see where it started off, but we see how many iterations it took to get to some sort of result. So I'm not sure, for example, if in this case it's not reaching a result and the error trend is 8.8, yeah, it just stops trying. I guess because it's already saturated, so the error trend just it doesn't change anymore. So after that many iterations, the 2500, it just stops. It just stops the iteration. Yeah, interestingly, it takes longer for it to settle. So when you have a small training set, it takes bugger all to reach a goal, even if it's not what you would expect. But yeah, no, so I think we actually improved this quite a bit. And for us to the other thing is when it's I want to see what its default settings are. Yeah, that's the version I haven't updated yet, but yeah, I think we have a better version now.